Доброго ранку, Киев! Як поживаете? Как дела? Хорошо? Хорошо. All right. So, I was in a conference a couple of years ago, and I overheard a conversation of someone saying, "You know, Zurich, it's so boring, and Switzerland, it's so boring." And I'm from Zurich, I'm from Switzerland, and I'm going to tell you it's not boring, right? So if you have the chance to visit Zurich, definitely do so, because right now they are preparing something, a wonderful tradition that we have in Zurich. On Monday, they're going to actually build a huge bonfire and put an artificial snowman on top of it, as you can see here. And this artificial snowman then sits on top of that bonfire that is being lit. So you see, the bonfire is, well, on fire. And what happens when you light some fire under a huge artificial snowman? It catches fire at some point. And you know what happens? Because we do something very special with it, we actually fill that snowman with explosives so it blows up. How is that boring? Right? And when asked why we do that, the reason is because, and then people look at you strangely and you're like, okay, I can't say because it's fun. So because we want to say goodbye to winter. To which I then ask, in April, in Switzerland? That is very optimistic. But yeah, the best thing is we have data, like there's historical data sets that show you, because there's this legend. The legend goes, the longer this thing burns before it blows up, the warmer will the summer be. Now, Switzerland wouldn't be Switzerland if they wouldn't be very exact about things, so they have data to prove that it's not true. But yeah, anyway. So this time here, we are all gathered to learn more about how a pixel actually gets on screen and how all the things that are in between hopefully do not get in the way with that. So we're going to talk about all things rendering. We're going to talk about layers. We're going to talk about CSS. We're going to talk about Canvas. We're going to talk about WebGL for a short moment. But before we do that, I'd like to take this opportunity, now that we are all here in this wonderful large hall, to talk about something slightly different, because we are all here as developers, and we know stuff is hard, and we know it can get confusing, and there's a lot of moving targets around sometimes. By the way, this infographic absolutely made sense at the time. It's from the Swiss television explaining some weather phenomenon, and I love how they just put question marks all over it and went like, weather, right? So all this is hard, and we're all very familiar with software and computers, right? Because there's a lot of stuff that can go wrong. We're building layer on top of layer on top of layer, and then our hardware and software gets put into places that it was never designed for, especially the web. The web was designed to basically exchange research papers across the entire globe. However, we're now building applications with it, which is super cool, but it's super tricky sometimes because it was never actually meant to do that. And we know what happens when stuff is used in ways that are not meant to be done with it. There's one other example that is, there's this max data or max IP or whatever it's called, geolocation database that basically maps IP addresses to locations. And when they don't know an exact location, they go to country level and they pick random points for each country. And unfortunately for the US, that is one particular farm in the middle of nowhere, and they get like threads, and they get people visiting them and shouting at them because they stole their credit card details, and it's like an elderly lady. So data that is used out of context can actually be dangerous, and the same goes for software. So the problem with that is we do this a lot. We do this all the time, and software fails all the time, and we have to prepare for that. And the web is particularly resilient to it, but we all know how hard this can be. And we all sometimes sit in front of our computers going, this can't happen. Why is this happening? How did that happen? What the hell is going on? What am I doing here? Why am I putting up with all this, right? And it is very, very annoying because sometimes you have so many different moving parts, and some of these are actually not your sort of actually area of expertise. What if a disk drive fails in a data center and the admin is on holiday? Oh, that's probably bad unless you actually took precautious measures, right? So there's a lot of stuff in the stack that we have to at least understand from a basic principle and take the time to learn at least the basics of how things work. And then make sure that you at least, if you don't know something in particular, that you at least have someone to talk to if something goes wrong, because something will go wrong. And sometimes you're like, where do I even begin, right? A customer calls and goes, your website crashes my computer, and you're like, that can't be. I know for sure that can't be. And then they send you a mobile video that they took with their phone, and you see that your website opens, does stuff, and then the computer crashes. And obviously for them, it's you, right? That is your fault. I opened your website, stuff crashes, it's your fault. And it's really, really hard when you're in this situation, when you're put on the spot for something that you're not really responsible for. But we do this all because we want to make people's lives better. We don't want to come up with this thing and have to do this fix to make things easier. We want to build something that makes sense for our users and actually helps them have an easier life, even though they sometimes shout at us for sort of having certain errors or problems that might not even be our fault, right? The good thing is, we are not alone in this. So this is my lovely team in Zurich, or parts of it. This is Listoshkin, who's hopefully coming today. He's apparently running late. And this is a bunch of people I met at different conferences, and they're all awesome. And there's a large community all around the globe. Just check out Stack Overflow, GitHub, all that. We are not alone in this together. The next time you sit in front of your computer and go, what is happening? Why is this all happening to me? Don't worry, you're not alone. We're in this together. There's a lot of people who have to suffer from this kind of crap. And we have a lot of different tools and a lot of different building blocks we can sort of compose to large complex applications. And hopefully each building block is reasonably easy to understand and reason about so that we can actually figure out what it does and how it relates to the rest. And then we build very, very amazing things with it. I mean, you can build amazing stuff with Lego, but the actual simple Lego building blocks are not too complex to understand or make. However, as we have a lot of choice, it is sometimes very, very hard to go forward, especially with new stuff coming in. I heard the term JavaScript fatigue or JavaScript framework fatigue because there's so much new stuff. If I start today, what should I learn? Should I learn React? Should I learn Ember? Should I learn Angular? Should I learn Vue? Should I learn Polymer? Should I learn Fish, which is probably a thing that someone works on right now? You never know. Probably as I stand here and speak about it, there's like 10 new frameworks coming out. You never know. And then you might go, step back and go, I can't move forward because I don't know enough about the different choices that I have, right? And that is because we don't want to be wrong. You have to maintain your stuff, and you know that. And like, okay, if I do this today with this thing, I'm going to be stuck with it for the next couple of years. So I'm not going to make a mistake here. I'm going to be careful. However, check this out. Big revelation. It's all about choice and flavor and what works for you. There's no silver bullet. There's no simple one solution that's going to fit all your problems. There's always going to be problems. We are problem solvers. We, as software engineers, are problem solvers. So if there would be no problems, we would have nothing to solve, hence not have a job. All right? So don't worry too much about your tools. Pick the tool that you are familiar with good enough to know that you can do the thing you have to do with it. Make sure that your team agrees on the tooling. It doesn't matter if it's Ember or Angular or whatever else, or, I don't know, Vardin or Google Web Toolkit or whatever. As long as you agree that this is what you think the best tool for the job that you all know, you're good, all right? Just make sure you don't get sort of this analysis paralysis and just go, I can't work because there's all these frameworks that I don't know about. Ignore that. Try to understand the problem. Fall in love with the problem, not with the solution. Fall in love with the problem and then try to find a tool that helps you solve that problem. And then you do the solution as you go along. You figure that one out with your team. That's what you have a team for, right? So again, technology and solutions are not as important as the value and the problem you're trying to solve for the user, okay? And if you try to sort of think of it from that perspective and just go, you know what? The technology is just a means to this end, which is the user has one problem less in their daily work or life. Then all these technology discussions become more intense, right? And speaking of intense discussions, So some tools are really, really simple, and then people go, ooh, this is just for babies, so go away with that. You can't really work with it, and you can't really build applications with it. Other people say, oh, this tool is super awesome because it's so simple, and other people say, hey, actually, this tool is not so good because it can't do all these magical things that I need to do, and I have this super powerful tool over here that can do all the things. It can't, all right? That's the first thing. The second thing is, just because it has all these options and it allows you to do all these things doesn't mean that you should be doing them. And if it solves the problem for them, that is cool, that is good. It doesn't make it a bad tool. It might just not be the tool that you are interested in, because you might be sort of going for a completely different problem to solve, or you maybe actually have different priorities. That is all fine. But please, please, please don't be jerks about it, all right? Oh yeah, I missed that one. That is terrific. Some tools actually need you to sort of get out of your comfort zone and put some effort in. So I had to take this video because this particular lady came to me because I was still having my my tablet in flight mode on my lap, and she's like, "Would you please turn that off?" I'm like, "It's in flight mode already." She's like, "No. Would you please turn it off? This airplane is a very, very sensitive device." Really? I see. Sorry. I won't do it again. Anyway, yeah, that was fun. So please don't be jerks about the tools you choose or the choices you make. We are all in this together, but that can only work if we are understanding each other and be nice to each other. These two ladies, by the way, that's Carmen Popoviciu from the Angular user group in Amsterdam. Brilliant, brilliant, bright person. That is Miriam Yessier. She's a marketing guru. Actually, she's amazing. She's a unicorn, basically. She does all the things, and she's from Montreal. Brilliant people, and you don't want to know how much online abuse everyone in the scene gets, especially if you're not male. So that's a problem. Please do not shout at each other. Please do not just assume that the other people sort of owe you something. Be nice, be friends, have fun, create stuff, solve problems, have beers. Awesome. Blow up snowman if you need. Right, with that all away, second part of this is about jank. So we want to make smooth and silky, nice applications on the web. And we're going to talk a little bit about that. Are you ready? Awesome. So first things first, what the hell is a pixel? And I hear a little murmur like, is he really asking that? A pixel is obviously a thing, a point on screen that we can draw to. Like all of this is a bunch of pixels. And if you zoom in really closely, these pixels here, not quite, but on normal screens, you actually have three little dots, one blue one green one red one, that make up all sorts of different colors when they light up. Now that's okay, we all understand that, but how does it actually work? Like, how does the computer know which pixels to light up? Well, there's memory behind it. So you have a bunch of zeros and ones somewhere in memory, then magic happens, and then you have a sparkling rainbow on your screen. Hopefully, or not. If that would be on my screen all day, oh my God, would I go bananas. So the thing in between the ones and zeros and the nice, sparkly, colorful pixels on screen is actually called the GPU. Sometimes it's the CPU doing it, or basically jumping in as a makeshift GPU, but there's this thingy in the middle that takes values and makes them colors on the screen. Cool. And this is how that works when the browser is involved. It's a little more complicated, I would say. So first of all, we have to get the DOM tree, so we have this file with basically a bunch of text. Then we build up a tree saying, okay, here's the HTML, here's the head with some stuff in it, here's the body, and then we have the render tree, which is, the CSS object model, which says, okay, so the body has this size, and the font size is 16 pixels, and then we have the paragraph, which sort of doesn't specify a font size, so it's also 16 pixels, I guess, and it should be bold, and you basically figure out, so this tells you what is it going to be that we're going to draw, and this is how is it going to look. Obviously, CSS is about styling, HTML is about what the hell we're actually styling here. And then you get this render tree, so the browser figures out, all right, so this one, okay, and this I have to make 16 pixels and bold, and I have the text, and it creates basically a bunch of instructions to draw on screen. So these instructions then go through an entire flow of things. First of all, if we actually have some JavaScript that influences the way that we are styling something, so the JavaScript changes the CSS that is applied by adding classes or literally just changing styles, or if it changes the HTML, so changes the content that we're going to see, then this is executed first. Then the browser goes, all right, I got this, and basically recalculates the CSS object model tree, the DOM tree for CSS, basically figuring out what to draw how. Okay, now we have that settled. Now, how the hell do the boxes, sorry, do the boxes fit together? How large are the boxes in the end? Because I have to put in, like, okay, I know 16 pixels is the font size, and I have the word hello. So how large is that actually in pixels? So it's going to figure out how these boxes sort of look like and how they fit together. My page is 500 pixels wide, and I have this box here that is 200 pixels, I have this box here that is 400 pixels. Ah, bugger, I can't make it like this, so I have to sort of put them below each other. That's the layout phase where a lot of shifting around and moving happens. And then it's actually going to paint stuff. So that means now it knows how to sort of, which pixels go where and how they're going to look. So now it actually goes and paints the pixels on the GPU, hopefully. And then we have a bunch of things, because it doesn't do that all in one go. It does that in parallel, so it knows I know how to draw this box, I know how to draw this box. So it draws that box in parallel. And when it's done, it has to sort of put them together into one large image that is what you see on screen. Okay. The first three steps, however, happen mostly on the CPU. There's implementation details involved here that make it slightly more complicated, but mostly this is calculations. So all the calculations happen on the CPU. Now the problem is JavaScript is single-threaded. So, and all this happens on the CPU. Even though the CPU can do multitasking, most of this happens in the main thread. That means if this takes a long time, this and that can't happen. And what happens if I don't know, this takes up time, this is running, I scroll around, which means I have to do all this again, but I can't because my JavaScript is now running, my main thread is blocked, I have to wait for the JavaScript to finish, and then the scrolling happens, and that's super weird, because I scroll, nothing happens, scrolling happens. Like, what? That's jank, and that's what you want to avoid. Now we have talked about CPU and GPU, or I have at least mentioned them, but what the hell does that actually mean, and how are they different? Well, the CPU, the central processing unit, is literally the thing that does all the things, all the calculations, and can do all the calculations. It has to run a bunch of programs in the background. It has to run your operating system, it has to run your browser, it has to run all the pages in the browser, it has to do whatever else happens in the background, it has to do the networking, it has to take keyboard inputs, it has to take mouse inputs, all that. So there is very, very general purpose, but that comes as a cost. The cost is sometimes things depend on each other. I can't, I don't know, read a file when that file hasn't been opened from disk, so that it sort of has to know when is the stuff coming from disk into my memory, so that this program that wants to get the data from this file can read it from memory. So there's a lot of dependencies, and it has to be really, really clever, and they're freaking complicated. However, there's also the GPU. The GPU, on the other hand, has a slightly simpler task. The GPU's task is basically, I have stuff in memory, I have ones and zeros in memory, and I'm going to put them on screen. There's not that much involved in it. It can do very complicated things, but the simplest GPU just reads stuff from memory and puts it onto screen. And the cool thing is with this, if I know my ones and zeros are always there and always have to be just pushed over, then I don't care about dependencies. There's not like this pixel is blue if this other pixel is green. That's the problem of the CPU. That's none of my business as the GPU, right? I don't care. So you can actually parallelize that a lot. So you don't have to go like pixel 1, pixel 2. You can do, yeah, all the pixels, woo, and you're done. That is nice. And why is that so important? Well, if you think about it, a full HD screen has 2 million pixels. And then 3 byte per pixel if you use 24-bit colors, 4 byte if you use alpha channels, and that's like 5.3 megabyte. That doesn't fit on my floppy. Damn it, right? Reminds me of this entire, just imagine that you want to have one frame of an image, of a game, and you go, okay, insert disk 1 of 5. That's pretty bad. Okay, 1 of 5. Okay, and then next one. Oh, all right, I see. Okay, he's gonna shoot me soon. Okay, 1 of 5, 2 of 5. I'm dead, come on. How did that happen? You're cheating. You're using aimbot. So basically what we're doing is, when we're in the browser, we say, hey, main thread, if we use the CPU, hey, main thread, could you do me a favor and draw 2 million freaking pixels in 10 freaking milliseconds, because you know I want it to be 60 frames per second and nice. Nitpicking, this is theoretically 16 milliseconds. However, the browser has to do some stuff as well, so we pretty much get 10 milliseconds. So you're like, hi, can you please draw me like these 2 million pixels? By the way, you have 10 milliseconds, bye! And what happens on the CPU is this. That's not optimal. So how about we ask the GPU? And the GPU goes, sure, because you know I do these like 5,000 pixels in one go and I'm good. So that's exactly why we care about the GPU. It's just more relaxed and more specialized on the task at hand. However, we don't have to worry about that too much and all the time, because the browsers are doing some stuff for us, which is convenient. First of all, it basically separates each website into a bunch of tiles and then figures out how to, redraw the tiles if things change. And tiles come from the concept of having multiple layers, because obviously I have the page that is the layer on the very background, and then I have things on top of it, and maybe I have like a navigation, and in the navigation I have one link, and in the link I have text, so you can basically layer things. And these layers then are broken up in tiles, and that means basically I have a bunch of small images that I can put on the GPU memory and I never touch unless they change. So the CPU does not have to render all the things again and again. It just goes like, okay, this image and that image changed, so I'm just gonna push these 2 images, and the GPU goes, yeah, whatever, I'm already done with that stuff, that's good, it's fine. And the cool thing is the GPU, as it is a little more clever than I made it sound, can also do things like scaling things down or scaling things up or rotating. So that's all these CSS 3D transitions and animations that you heard. Because the browser doesn't have to redraw all these things. As long as you just rotate something or scale something up or down, it can go like, yeah, whatever, just, hey, by the way, GPU, that image that I gave you earlier on, just make that larger, all right, thanks. So no real effort for the CPU. No, I have to redraw this image, which is nice. Same goes for maximizing, minimizing, and scrolling. All right, and this is how that might look. You can see that it basically contains the amount of stuff that it redraws, and basically it just has to change. Whenever something green is in a tile, that tile has to be re-uploaded to the GPU. But that's fine, that's relatively quick. So that's what tiles are about. That also binds into CSS triggers. There's this brilliant website called css-triggers.com, and you can see which part of the pipeline happens when you do certain things, when you change certain values. So for instance, if I change align content in Blink, that causes everything. So the CPU has to relay out, and then after the relay out, it has to paint, and then when it's painted, it has to composite. While on Gecko, for instance, they are clever enough to not have to do the relay out and the repaint. They just recomposite, they just move things around. Oh, that's cool. So this is a really helpful website that explains how these different things sort of work. Obviously, the problem is when you change that as you go along, then it actually repaints all the way. Relayouts, repaints, recomposites all the way. And then there's the possibility to basically contain changes, and we can see that here. So here you see a faint green rectangle, and this blue thing just hops from left to right a bit, but this entire rectangle is redrawn. So we are redrawing a bunch of pixels that don't really have to be redrawn. Here, this is on its own layer. This div is on its own layer, and it's not being redrawn. There is no green rectangle that says, I'm going to redraw this crap, because it's not being redrawn. The GPU, this is entirely happening on the GPU. The GPU just jiggles it around, and the CPU just flips bits. It's like, yeah, move it, and then the GPU goes, move it, and you're done. That's exactly what you want. However, we're limited in memory. And because we are limited in memory, and we have no idea how much memory we actually have, we can't make everything a layer. The thing is, it's not going to crash unless you're on an old Mac. Fun story ahead. If you're on an old Mac, it might actually crash the browser, but however, if you're not on an old crappy Mac, then you're actually safe. However, it gets really slow when it has to sort of take memory out into some other parts of the memory and then move them back in. That gets slow, so don't make everything a layer, even though it might seem an easy sort of one-size-fits-all solution. And we have other ways as well to sort of make sure that we are on an isolated layer. If we want pixel access, we can use the canvas, which is cool. So we use the canvas, and we get pixel access, and we are fast, and we are hardware accelerated. Woo! That's not quite true. So first of all, text rendering is still really, really slow because it has to, figure out what pixels go into drawing a character, then it draws the character, and that takes a little while. Also, scaling images, if you do that in JavaScript on the canvas, actually that is not happening on the GPU. That is still happening on the CPU, which we know is slow because it does 1 pixel by 1 pixel. You don't want to get yourself into that. Also, you have to make sure that you're not basically copying around a large amount of pixels because that also happens on the CPU, and also not good. So it's a bit tricky. And you can see that here. So here right now, I'm moving this piece here with the code. I just say like, I have this rectangle of 300 pixels, and I'm going to move it around and then just swap back once we are out of the canvas. But the entire freaking canvas is being repainted. Ugh. Right? So how about this one? This only repaints the small rectangle, but I had to do that in freaking code. I have to make sure that we are only filling the part that I have to sort of make redraw. Actually, I could optimize that and just, anyway, it doesn't matter. So the point being is, it is annoying. You have to put work into not making it slow. And how much slower is Canvas compared to WebGL? If you have a lot of objects and complex things that happen, for instance, 3D transformations and stuff, it is reasonably slow. So the blue boxes are Canvas. With 250 objects, we are far below 10 frames per second. That's like 5 frames per second. That's a slideshow. That's not a game or something. Here, however, WebGL doesn't care because it just uses the GPU most of the time. So right, it goes like, yeah, 250 objects, sure. So what is different in WebGL from the canvas is it gives you parallel access to the GPU, parallel pixel access, and that is cool. Also, it doesn't just give you pixel access, it gives you access to code that runs on the GPU. So you can write code that runs on the GPU. How cool is that? This code lives here, that's my code that I write, and it goes into 2 steps of a pipeline. And the pipeline more or less goes like this. I have a bunch of points that I want to draw, and I have a bunch of lines in between the points. I put these into a bunch of memory buffers, basically, and then one program is called. It gets each point, and the program, all it does is it changes the point around. Basically, it gets a point, it goes, move that over there, move that over here, and how it moves things, I have to program. The easiest motion is no motion. It just takes the point and passes it on. Cool. That works as well. Then the GPU does some magic to actually give me pixels because my points might not actually line up with pixels. Just imagine I have like these 2 points and they are really close to the camera and then they go deeper into the screen, and if it's a perspective camera, then they get closer to each other. So figuring that one out and then actually figuring out what pixels we have to get is work that the vertex shader and the rasterizer do together. Then for each of the pixels that I have to color in, another program that I can write is executed called the fragment shader. So the fragment shader gets a position and some information like, is there any image that I should apply? Is there light that I should apply? And basically figures out what color to put. And then you put the color on screen. All the green stuff happens on the GPU. Only the blue stuff is JavaScript. The red stuff is GL slang, which is a strange language. If you're interested in how shaders work, I am going to do a workshop later on today. So pop by if you're interested in programming the GPU with GL slang. So again, basically, shaders are just functions that take data in and put data out. And because they just have an input and an output and don't know about the other inputs as well, they are basically functions. And these functions can be relatively complex. However, they are always pure because they are never actually having side effects that do not allow us to parallelize them. So these programs run in parallel, which is cool. So in summary, browsers are clever, don't worry about that. However, try to do as much on the GPU and not on the CPU as you can to sort of get SpongeBob to calm down, right? Be aware of layout and paint events. They're reasonably, or even worse, like the JavaScript that works beforehand. And also Canvas, while it gives you pixel access, does not always give you full hardware acceleration. It gets you some hardware acceleration in the sense of the pixels are being drawn on the GPU, sure. However, having to redraw them still is a performance issue. WebGL, on the other hand, is basically GPU bound. That means it gives you parallel access, and most of the stuff you do is actually happening on the GPU rather than the CPU. And last but not least, as I said in the beginning, we're in this together, you're not alone. Pick the tool that makes sense for you and the team and the problem at hand, and don't be a jerk about it. If you choose React, cool. I'd like to hear about how that works out for you. If you choose Angular, same. If you choose Ember, same. If you choose Vue.js, same. If you choose Aurelia, fine. It's all cool. But don't shout at me because I chose something different, all right? You might not understand my problem or my users' problems. And last but not least, don't panic. Things will fail. It'll be good. Unless you work like in nuclear power plant software or airplane software, then things might slightly be different. But yeah, just, have fun, create stuff, help your users lead a better life and easier life. And with that, дякую, and I'm done. Before we all wrap it up, give a round of applause to the organizers who make this all possible together with the sponsors. So I think it's the time to say thank you to the sponsors and organizers. And now it's time to enjoy the conference. Woo!
Martin, maybe there are some questions?
Oh, are there any questions? Well,
are there any questions?
I'm on Twitter, I'm here, just ask me if you're having questions, or just ask them now. Do we have time for questions?
We have time for 2 questions.
All right, 2 questions. Now is the time.
No questions?
Now is the best time.
Okay.
Now is the best time to ask questions.
Hi.
Hi.
Can you tell what is current state of efficiency of Flexbox rendering?
Flexbox rendering. So as far as I can tell, Flexbox, as it gives you a bunch of controls over how things sort of lay out, it's mostly with you. You can still possibly write inefficient Flexbox code. However, browsers optimize the layout at least for you. So because the layout rules are simpler in the sense of more predictable, it is more predictable for the rendering engine. Hence, it can actually avoid a lot of complexity in the layout code. It might do layouts, but the layouts might be less complex than the layout path it goes for non-Flexbox layouts. So performance is reasonably okay. I don't know the browser details. I might be the wrong person to ask for that. If you want in-depth information, ask Rachel Neighbors or Rachel Andrew. These 2 are the best people to ask for Flexbox performance. I'm more a WebGL guy. I don't care about CSS that much. Second question.
One last question. Your last chance.
That's actually not true. I'm around. You can always ask me questions.
Till 6 o'clock. No, till 3 o'clock tomorrow. Till 3 a.m.
In the morning.
In the morning.
Yes, because screw me.
3 a.m.
Yeah, my flight leaves at like 6. I'm really good at calendaring.
If there are no, okay.
You've all given up. Cool. Enjoy the conference.
Wait, a question. Where would you recommend to use WebGL components?
Sorry?
Where would you recommend to use WebGL components? Let's say in sliders, on the front end, or, or on the games?
Okay, no. All right? Everything that is existing as a DOM element, use the freaking DOM element for one simple reason, accessibility. The browser does a lot of things to make all the certain DOM elements nice and fine, even for users who can't see, who have to use keyboards, or who have to use screen readers, or who are impaired with motoric dysfunctions. Don't re-implement the DOM in Canvas or WebGL. Do not be Flipboard. Thank you. It's cool, it's nice, I love them for doing that, and it's an amazing thing they built. However, I wouldn't use it. WebGL makes sense if you want to have 3D data or graphical data. It could be 2D if you do certain transformations that are very, very expensive on Canvas. If you build Photoshop in the browser, WebGL is probably the way to go, for instance. Or if you do like shameless plug, this company that I happen to know actually has a 3D editor in the browser for real estate. Makes absolute sense. So that's valid use cases for
Thanks.
WebGL. Welcome.